welcome to the Sun Today for the 1st and 2nd of February 2022. Let's summarize what's been going on. We can see from frame 1 here that there was a mild disturbance in the magnetosphere late last night, but since then it has calmed down. The sunspot number is hovering around 80 still. Frame 3 shows the sunspots, and we have a couple of small new regions, one in the southeast and one in the northwest. The other regions seem to be fairly stable, with the exception of 2940, which still seems to be growing somewhat. We've had a large number of small C flares and 4 fairly significant C flares, a C9, a C7, a C9, and then a C8 in that order. So let's take a look at some movies. We'll start at the surface of the sun and then move outwards and upwards in temperature. So we're starting with the sunspot movie from the Solar Dynamics HMI instrument, which has a characteristic temperature of about 5,000 degrees. What to look for here is large sunspots, emerging regions, decaying regions, and motions. Sunspots are areas of strong magnetic field, so the next obvious thing to look at is the magnetogram movie. Around each sunspot region, there's usually an area called plage. These are bright areas which are emitting more radiation than the sunspots. To look at those, we use the 1700 angstrom continuum channel from the Solar Dynamics Observatory AIA instrument. You can see here the sunspots clearly, and the plage are the bright areas, but also the flares show up as little brightenings within those regions, so you can see where the flares are occurring with respect to those sunspots. Above the photosphere is the transition region. This goes from the temperatures of the photosphere all the way up to the temperatures of the corona, 2 million degrees. The line we're choosing to use here is the helium-2 channel from the SDO AIA instrument, and that has a typical temperature of about 50,000 degrees. These enable you to see prominences. Those are bright areas above the limb of the sun, and filaments, dark areas on the surface of the sun. They're actually the same thing, and you can also see eruptions of those as time goes by. We move up in temperature now to about 630,000 degrees Kelvin. That enables us to see the lower corona using the iron 9 171 angstrom channel from AIA. Here you can see magnetic loops, interconnections between regions, changes in those, and also the dynamics of the regions. Now again we'll move higher. This is the iron 12 channel at 193 angstroms. This looks at the so-called quiet corona at a temperature of about 1.2 million degrees Kelvin. Here you can see what's called the magnetic carpet. This is low-level magnetic connections, and far from being quiet, they're changing all the time. You can also see coronal holes. These are the dark areas. There's 2 that's fairly prominent at the moment. Those are at the poles. And then there's also some transequatorial coronal holes, which are often the ones that produce geomagnetic storms at Earth. Higher again in the corona, we look at the active corona using the iron 14 line at 111 angstroms. Here you see active regions, and on the limb you can often see dark areas, which are sometimes called tornadoes because they twist around. These are, again, prominences seen in absorption in this particular channel. Now we're going to look at the active regions themselves. These are the regions above the sunspots, and we're going to use the iron 16 line at 335 angstroms from the AIA instruments. The typical temperature here is about 2.5 million degrees Kelvin. So you'll see the active regions, and you'll see some of the flares as brightenings in those active regions. If we want to see flares, we have to look at really hot plasma, and to do that we're going to look at the iron 18 line at 94 angstroms, and that's got a typical temperature of 6.3 million degrees Kelvin. Here you'll see the active regions, but also you'll see the flares much more clearly as bright bursts in those regions. The hottest temperature that the AIA instrument can see is the iron 20 line at 131 angstroms. So this is really good at looking at flares because the temperature maximum of that particular line is about 10 million degrees Kelvin. In order to see the outermost layers of the solar atmosphere, the high corona, we have to go to a different spacecraft and a different type of instrument. Here we're going to go to the SOHO spacecraft and look at the Glasgow C2 coronagraph, which is a high-resolution imager of the inner part of the outer corona, if that makes sense. And here you're going to see coronal mass ejections. If you want to observe beyond the field of view of the C2 coronagraph, you have to go to the C3 coronagraph, which has a much larger field of view. You can still see coronal mass ejections, but now you can see planets wandering by the sun and also sun-diving comets if you're lucky. Well, for Earth conditions, we need to know what the solar wind is doing, and this is a 3-day plot of the solar wind. You can see that BZ has moved to the south, which is usually an indication that it will reconnect with the Earth's magnetosphere. The density is still around about 10 particles per cubic centimeter, and the speed, interestingly enough, has dropped to about 425 kilometers per second. In fact, actually, the most recent reading was just over 400. As I said earlier, geospace is quiet. This is the planetary K index, and it's dropped to 2 at the moment. However, there is some expectation that it will get more active this evening or tomorrow. One of the major effects of space weather is effects on communications, and particularly in the ionosphere. And D region radio absorption is a significant factor there. I'm going to show you a movie of how that is likely to be affected over the next couple of days. Here's NOAA's auroral forecast for the next couple of days. So what conclusions can we draw from all of this? Well, the sunspot number is high for this point in the solar cycle. It's well ahead of what the models were predicting. We see the number and intensity of C flares building and thinks it's possible that there's at least an M flare on the way. We've had several CMEs, but none of them seem likely to be affecting Earth in the near future. So, thank you for listening, and until next time, stay safe and goodbye.